Nope. This is how you order hash browns at a restaurant chain in the U.S. called Waffle House. The Waffle House language has 8 inflected verbs, and that tells you tells them how you want your hash browns. The alternative is to go into Waffle House and say, okay, there's this plant, it's a potato, it's a root, it grows underground, you pull it up, you wash it off, you peel it, you chop it up into little slices, you put it in a pan with a little oil, you cook it until it's brown, and you drain it and you put it on a plate. Okay, I want cheese. Okay, there's this animal called a cow. It would take you too long to order hash browns if you had to explain every single step of the process to the person you're ordering it from. In fact, the person behind you in line is going to kill you because they want hash browns and they want them as fast as they can possibly get them. But when you think about it, when we write code, we're doing exactly that. We're explaining to the computer in ridiculous detail how to do stuff when we'd rather just say, I want hash browns. Jargon is why musicians who have never met one another and may not even speak the same language can get together and have a very short conversation in their language and play together like they've played together their whole lives. I'm not even going to try to read this one. This is called Leetspeak, L-E-E-T speak. This started out in the gaming community, spread to SMS messages, and now this is a legitimate jargon. In fact, there's a Wikipedia entry about this, so it must be true. It has its own grammar rules, it has its own syntax, it is its own language now. And when you think about it, all non-trivial human behavior has jargon attached to it. Think about sports. A bunch of my colleagues are really into cricket, and I don't know anything about cricket. I've tried to figure it out, but it's really hard to figure out. And when I walk up on them and they're having a conversation about cricket, they're using English words, but I have no idea what they're talking about. Because they're using a bunch of terms that I don't have any context for. And this includes your job. That's why developers tend to stay within certain technical realms like Java, but also within particular business domains as well. So if you're a Java developer working in insurance, when you start to look for a new job, it's probably going to be writing Java code in insurance because you already know some of the jargon of the insurance industry, which makes your job a lot easier. Because it's how non-developers talk. And you may ask this question, non-developers, who are those people? Those are the other humanoids that occupy your meat space. Oh, okay. I understand now. It's those people that keep giving me requirements and stuff. But business jargon really is a domain-specific language. So if we can write our code closer to the jargon that the business people already use, that means they have a fighting chance of being able to read our code and understand what we're writing code for. So let's talk about some definitions. These are all definitions that Martin Fowler has coined as part of his research and development into domain-specific languages. He defines a domain-specific language as a limited form of computer language designed for a specific class of problems. Now, you can definitely get too far and make your definition of DSL so broad that it encompasses everything on Earth. And we don't want that. We'd rather have a nice, narrow definition. And this is a pretty good, fairly narrow definition of what a domain-specific language is. And building on this, language-oriented programming is this general style of development that operates around the idea of building software around a set of domain-specific languages. That's the idea behind language-oriented programming. You may look at this and say, well, I've already got something like that. I have APIs. So how is this different from a regular API? Consider this example in Java. This is kind of ironic because this is how you would order coffee in Java. So I kind of like the irony of ordering coffee in Java. And as Java developers, we look at this and go, oh yeah, that's just simple Java code. But look at it from different eyes for a few minutes. Think about if you were a non-Java developer, look at this and notice how much repetition there is in this code. It's the same stuff over and over again, and that's just the stuff that has to do with the domain. If you start marking off the other stuff that's repetitious too because of Java, you get even more repeated stuff. This is the way that we talk to our compiler. This is the way that we talk to other humans. And in fact, in this version, the word coffee doesn't even show up anywhere. But you know, somebody noticed right away when I showed this, oh yeah, that's Starbucks DSL. Because the human brain is really, really good at supplying context. With just the barest clues, you can supply the context for which this language makes sense. And once context is established, repeating it over and over and over again is just noise. And that's the problem when we try to show non-developers our Java code. All they see is noise because it's the same stuff repeated over and over and over again. What we'd like to get to is more and more declarative code. Like this. When we say select star from customer, we don't have to tell a database server how to allocate memory or where it lives in the file system or how to use indexes or any of that stuff. We declare our intent and it just happens. And it brings it back to us. This is declarative code. This is one of the reasons why people are so irrationally excited about Ruby on Rails, because this is the way in Ruby on Rails that you define validations for your web form. It's very declarative. You don't tell it how to do this, and yet by saying validates presence of name, that handles the database validation, the business logic validation, the UI validation, and all the workflow stuff that goes with that. Just by declaring that one intent, all that stuff just happens. And the more we can write code like this, the less we have to explain to the computer over and over and over and over again how to do stuff. Now, there are two fundamental kinds of domain-specific languages. The first ones are internal DSLs. These are DSLs written on top of a base language, like Java, or like Groovy, or like Ruby. And that means that flexible languages make better bases for these DSLs. The other kind of DSL are external DSLs, which are ones that are languages that you actually parse and lex and process yourself. So let's talk about these two types of DSLs for just a second. And first, I'll talk about internal DSLs. And as part of talking about internal DSLs, I'm going to talk about a few DSL patterns along the way, because we've done enough of this now that we're starting to see patterns in how these things work. And the main pattern that I'm going to focus on here is one that's used a lot now, is this pattern called fluent interface. Here's an example from a project that I was on. This is a project about leasing rail cars. And rail cars have a lot of really elaborate rules around them. For example, if you have a tanker car and it normally hauls milk, if you ever haul tar in it one time, you're no longer to ever haul milk in it again. And that's a perfectly good business rule as far as I'm concerned. I like that rule. We were building an application that dealt with leasing train cars, and so we would have pages of this kind of stuff. And we would try to show it to our business analysts to say, okay, we need to test this one characteristic. Is this the right kind of thing that we're testing? And they would look at this and say, I don't want to see that Java code. That just looks like Java to me. They can't really see the meaning because there's so much noise to them. So we rewrote our API into a fluent interface that looks like this. What we managed to do is boil away enough noise so that they could read this now. And they were perfectly happy reading this. I mean, as far as they were concerned, there were a couple of odd, parentheses and that kind of stuff, but there was enough noise eliminated so they could actually read this. And we didn't have to go download a giant framework or do anything special or magical to make this work. All we did was make our set methods get rid of the set on the front of them and have all of them return this.